Bienvenidos, Ushamdi, and welcome CTS231, Section 841 students for the second 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 4, or the Connecting Networks V6 course, brought to you by Cisco Networking Academy. And this is going to be a tutorial and solution set on Packet Tracer Activity 4.2.2.10, where we're going to be taking our first look now at configuring extended ACLs. So let's go ahead and jump in here. You can see we've got our addressing table over here to the right. We're simply going to configure and apply and then verify an extended numbered ACL, and then we're going to be creating a named ACL. Now remember, the key thing with ACLs is that they are stateless, right? They don't keep track of any state information. They are simply a packet filter. So in other words, we're going to be looking with extended ACLs. We're going to be looking at the layer 3 and possibly the layer 4 information, right? And depending on how we construct the ACL, and I can guarantee that in this setup here, we're definitely going to be looking at the layer 4 information. But extended ACLs are layer 3/layer 4 packet filters. That is all they are, right? Standard ACLs are simply layer 3 only packet filters, and not only are they only layer 3, but they are only layer 3 stateless packet filters on the source address, right, in that TCP header. So standard ACLs, stateless layer 3 only, source address. And then we've got extended ACLs, which is our focus here. Again, layer 3 and or layer 4, as well as the port numbers, the source destination IP, the port numbers. We can do a range of port numbers. And so that's what we're going to see here. So we're going to configure, apply, and verify an extended numbered ACL. Now remember, the numbered ACLs are going to start at 100 and go to 199. Then we've got an extended range that we could use as well. So let's jump onto router 1 here, and let's go ahead and get this going. So we'll get onto the CLI. I'm glad we've got the router here so that we can have a nice robust font. And let's bring that back up. It disappeared on me. And the window is a little behind. Whoops. And we don't want to do that. And I'm not sure what just happened here. All right, and I don't know what port we were in, so let's choose gig 01 there. Yeah, the window's dragging behind a little bit as I go to expand. There we go, as I go to expand the size. So hopefully that was in gig 01. All right, so here we are. We'll go from user exec to privilege exec, and then I'm going to go into global config. And again, they have, they kind of walk us through it, right? It's a nice sort of a soft landing over here. So if I was to say access list and then do a question mark, you can see we see the standard range of 1 to 99. Then we see the extended range from 100 to 199. Now, if I were to pull up a real Cisco router, which this guy is right here, and I was to go into global config and say access list and do a question mark, you can see that there's a lot more that's going to be going on. And I apologize, for some reason my mouse is not grabbing. Yeah, it's just sort of dragging behind here. So, but I think you get the idea here. There's a lot more going on, right? And so the IP standard ACL expanded, I should say expanded range, not the extended range. The expanded range is 1300 to 1999, and we read about this in the chapter. And then the IP extended ACL expanded range is 2000 to 2699, right? So in case you get outside that standard allotment there of 100 ACL numbers that we can use for standard and extended, then you could go ahead and transition. Okay, all right, I'm sorry, 99. So here we go. So access list, I'm looking back over here to the right. So we're going to use 100. We're going to pick the first extended ACL number that we can use. And we are going to permit, and what is it asking for? It says on step D here, this is where we're at right here. So this ACL permits FTP and ICMP. ICMP is listed above, but FTP is not. And that's because FTP uses TCP, right? And ICMP simply uses ICMP. So we're going to go ahead and say permit TCP. And what are they looking for here? They kind of walk us through it, so we want to make sure we get the right addresses in here. And we're going to go ahead and apply it to 172.22.34.64. And now if we do a question mark here, you can see we need the wildcard mask. Now remember that the wildcard mask is nothing more than the inversion of the dotted decimal subtracted from the all 255s. And this is another way that you can figure it out, right? So let's pull up our pen drawing tool here. So there's two ways that we can do this. So we know that if we know the dotted decimal, and we know that the dotted decimal is 224, right, because it's a /27, I could simply say all 255s, and so we would say 255.255.255.255, right, the all 255s. And from this, we're going to subtract what the net mask and dotted decimal notation is. And so I'll just do this. 255, 255, I'm just putting quotes here, 255, and then we get down to 224, right? So it's going to be 0.0.0, whoops, 0 dot, and 255, if we subtract 224 from 255, we get 31. And that's one way to do it. And this is absolutely fantastic here. They show you another very simple way to do this. So if you know that it's a /27, we've got 8 bits there, 8 bits there, 8 bits there, and then 3 bits here. So all you would have to do is figure the value out of the low order remaining bits here, right? And so what do we have? Well, remember, when we're talking about binary, it's 128, then 64, then 32, but then we have 16 and 8 is 24, 4 is 28, 2 is 30, and 1 is 31. So this might be another way for you to go ahead and figure it out, right? If you're not comfortable with doing the subtraction piece here, because maybe they only give you that. And really, maybe that's the use case, right? If you don't have these memorized and you see /27, then you know, hey, it's only going to be the last 5 bits here, because we're borrowing 3 host bits, turning them to network bits. So there's only going to be 5 host bits left. So then calculate the value of this instead of having a 2-step process where you say, okay, /27, if you've got to write out what the 27 looks like here to figure out, okay, so that bit's borrowed, that bit's borrowed, that bit's borrowed, so I've only got these 5 host bits left, and then to try to sort the 224 out by adding the first 3, the high order bits here in the last octet, to get 128 and 64 is 192, and 32 is 224. So instead of doing that math, maybe this math is a little easier. So you've got 2 options here to come up with that wildcard mask. I'm actually really happy here that they threw this in here, because I typically don't use this method. But again, if you're presented with only the subnet or the CIDR notation, this appears to be a little easier just at first blush. So definitely 2 different ways that you can tackle the wildcard mask. So let's put our wildcard mask, whoops, let's get our wildcard mask in here, 0.0.0.31. Now again, remember, the extended ACL, we're using layer 4 information with TCP, and this is the from. So what we're saying is, in this extended ACL, we're going to permit TCP traffic from that range of addresses, or addresses that are in use in that subnet right there, that /27 subnet. And let's play this out here. And who are we going to allow it to go to? Well, we're going to allow it to go to the host at 172.22.34.62, right? And that is in 22.34.62, and that is in a different subnet. All right, and they kept the subnet numbers pretty close here to make it a little more difficult. Now we're going to go ahead and say equal. right? And this is the TCP, and let's make sure that the FTP. So equal to FTP, and then we would do a question mark here, and you can see those are the choices that we have for our extended ACLs. Now it's got a little note down here. It says create the second ACL to permit Icmp ping traffic from PC1 to the server. Note that the access list number remains the same and the specific type of Icmp traffic does not need to be specified. So we don't need to say Icmp echo or reply. And in some cases, if you're trying to lock your environment down, you would do that. But here, we're not going to be doing that. So there's the first ACL entry. So let's get the second one in here. So we're going to say access list 100, permit Icmp, and it is going to be much the same. So 172.22.34.64, and that's our subnet ID. We know the wildcard mask, and we know we're talking about host 172. And remember, we talked about this on Tuesday night. That host keyword there is what allows me to avoid having to say this, 0.0.0.0. Right, so that's another way to do this exact same thing with the host statement, is to simply put in the IP with the quad zeros, because the quad zero says, yeah, no, I'm matching this exactly. We're going to match it exactly, but again, the easier way and the way to use it with that keyword there is host 2234.62. And if I do a question mark here, you can see that here's where we would get the options. We could do Icmp type numbers. We could do Icmp echo, echo reply, host unreachable. So, you know, an opportunity to narrow it down and to scope things down and to be very granular with the types of messages we're actually permitting here. So we're going to go ahead and hit enter there. Now it says apply the ACL on the correct interface to filter traffic. So let's think about this. Remember, extended ACLs. What is the rule with the extended ACLs? Do we try to apply it? And I'm going to stress that word try, and I'm going to explain why I'm stressing that word try. Because it's not always optimal to do it as close to the source as possible. In some cases, we may want to move it a little further away. Because remember, with standard ACLs, the rule is, with the standard ACL, we want to apply that standard ACL as close to the destination as possible, right? Because we're only able to filter on that source address. So we may block traffic that we don't anticipate or don't want to block if we're applying it as close to the source. That's why for the standard ACL, we apply it as close to the destination as possible. With the extended ACL, it's just the opposite. We want to apply the extended ACL as close to the source as possible because we've got some granular things that we can do here. So on R1, and let me scroll up here and get the whole thing in here. So here we are, we're on step 2, the correct interface to filter traffic. So we're talking about PC1 here, right? That .62, the 172.22.34.64, and we're going from that subnet to 172.22.34.62, which is going to fall 172.24.62. It looks like it's going to fall over on the opposite side. But here's what we want to do. So we want to apply it as close to the source because it's an extended ACL, and that would put us here on gig 00 on this interface right here. Because again, we're saying from that subnet. And so we want to get as close to that source subnet, and it could just be an individual host, but here we're doing a subnet, as possible. And here it is. That is the interface right there, the default gateway for that subnet. So now let's go ahead to jump back onto the router. We'll get into interface gigabit Ethernet 00, and we're going to say IP access group. Remember, it's access group, not access class. It's on the VTY lines where we would use that access class. So IP access group, we put the ACL number in here, and then what direction is it going to be? And again, directionality is important, and it's from the perspective of the interface on this router. So are we going in to the gig 00 interface, right? Is the traffic coming from that subnet inbound, or is it coming from that subnet outbound, right? And when you draw it out, it becomes kind of obvious here that we're talking about traffic from that subnet, so it would be arriving on this interface in the inbound direction, right? Coming off that switch, inbound onto that port. And so, therefore, we're going to say that it is in the inbound direction. Now, they walked us through that one, and here's what they want us to do. So, and actually, I'm sorry, it's not on this side. It's the server over here that's going to be the destination that we're trying to get to. So, verify the ACL implementation. So, ping from PC1 to server. So let's give that a try. And this is going to sort out whether or not we've got this correct here with this connection that we set up here. And unfortunately, I had grabbed it. It moved. So let's pull PC1 up, and we're going to ping the server. And what is the server address? And we'll give this a second here as it's thinking a little bit. And there is the PC. It opened up over here. And it's probably time for a reboot of this iMac, as it is running deadly slow here. All right, so let's go ahead and get to the desktop. We're going to pull up the command prompt. And we'll give it a second here. Boy, this is really running slow. All right, so here we go. So we're going to go ahead and say ping, and the server IP is that, oh, well, yeah, it's that 62 address. So ping 172.22.34.62. And let's see, can we ping? And the ACL is there so that we can ping. And all right, we even guessed the right interface when we hook things back up there on switch 1. So we can ping, right? Because remember, we were permitting Icmp, which is this ping traffic, excuse me, as well as FTP. So let's give FTP a try. So we'll say FTP 172.22.24.62, and we should get a username prompt. Now, here's what they want us to try. So can we ping from PC1 to PC2? And that's going to be 34.98, right? So we'll give that a try, 34.98. And this is where we should get the destination host unreachable, right? We're not getting the timeouts. We're not getting the period. We're actually getting something back. And who's it coming back from? .65. I can almost guarantee you that that will be the gig 00 interface on this router. Telling me what? Telling me that on this router, do show IP interface brief, we've got an ACL, and there it is, right? And so here's how you kind of, follow the path in terms of troubleshooting, is we see that we're receiving this message telling us, hey, destination host unreachable, and that's who's giving us that information. Well, when we look at our diagram, it's pretty clear that it's going to be that in this range right here, in 65, the first assignable usable IP is going to be on that gig 00 interface. So then I can come to the router, and let me try this one more time to see if I don't blow up the activity. There we go. And so what I could also say is do show interface gig 00, and when we're looking at the interface here, where are we at? And what am I'm missing something here. And I think I want do show access list. So we see the ACL, but we can see it on the interface. And what am I doing wrong? I'm missing something here. Do show interface gig 00. I thought for certain, maybe I'm just looking past it here, that it would show the ACL that's applied on the interface. And that's not the right command. And let me do this. Trying to remember here. Let's say show interface gig 00. No, it's not switch port, I don't believe. Yeah, no, it's not switch port. So I'm going to come back to that. I'm having a brain cramp right now. I can't remember the command to see the ACL listed on the interface. All right, so we've got that taken care of. We saw that the ACL is there. So now it's going to be up to us here on part 2. We're going to apply and verify an extended named ACL. And we're going to configure the ACL to permit HTTP. And we're going to do this again on router 1. So let's get into global config. And we're going to say it's a named ACL. So we start it with IP access list. And you can see we're going to have to determine, right, or we're going to have to define, is it going to be standard or extended? So here I'm going to say extended, and we know because we know we're using an extended ACL. And then the access list number, well, no, we're not using the number. We're using, because we use the number to go in to modify things, right? That's why that shows up there. But here we're defining what the access list name is going to be, and I'm looking over here to the right. So IP access list extended HTTP only, and now we go into the configuration section where we say permit TCP 172.22.34.60. Oh wait, I'm sorry, 96. We're going to be working on the other side here, on PC2 side. And again, we've got that net mask calculation. So here, right, great activity. They show you both ways to get this done. Now remember, if all I had was the CIDR notation, right, if all I knew was the CIDR notation for the 240, which is a /28, how else could I figure this out? Yeah, that would mean that a /28 would be the first 4 bits have been borrowed in that last octet. They've been borrowed for network bits. And then I've got 4 host bits remaining. So the first 24 bits over here are gone. They already have been used for the network portion. Then I'm borrowing 1, 2, 3, 4, leaving those 4. And these low order bits here, what are their values? Yeah, 8, 4, 2, and 1. And so 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So that would be the other way to do it if you didn't want to have to sort that out right there. All right. So we know that in order to indicate that entire subnet range, we're going to come in here and say 0.0.0.15. Excuse me. All right, and we're going to go to host, and this looks like the server, 172.22.34.62. Now, equal to what? What's the traffic that we're trying to specify here? Well, we already said it's HTTP only, so you should only be able to connect via HTTP. So we're going to say WW. Now, we're also going to permit Icmp, it looks like here. So let's go ahead and say permit Icmp, and it's very similar, 172.22.34.96. Let me make sure I got that right, 172.22.34.96, 0.0.0.15, and going to host 172.22.34.62. And there's no need, they don't want us to lock this down in terms of what we're going to allow to come back through. All right, so all other traffic is denied. Let me make sure we've got this right. All right, and so then we apply it, again, as close to the source as possible. So for this subnet here, the closest we're going to be able to get is right there on that gig 01 interface. Because if you're looking at the switches thinking, well, wait a minute, why don't you apply it there? That's closer to the source, or even here is closer to the source than here. The problem with that is that these are layer 2 devices, right? These are layer 2 devices. These are not layer 3. If these were layer 3 and we had an SVI, then I could go in there and sort of tweak things with ACLs, but that's not what we're doing here. So these are pure layer 2 switches, right? And therefore I can't filter on layer 3 and layer 4 information on the switch. It's got to be on the router. So I just wanted to make sure I address that, because if you're looking at this saying, well, this is way closer to the source, why not put it right there? Again, that's just simply a VLAN the definition on that interface, and that is a switch port. right? So it is a layer 2 port on that switch. All right, well, let's pull this back here and let's get back into the router. Whoops, get back into the router. And again, at this point, very simple, interface gig 01, IP access group, and we named it, right? So we need to make sure we get the HTTP underscore only, get the name that we used in here. And again, it's going to be in the inbound direction. So now we come to PC2, where we're going to say, let's get the desktop up here, moving a little quicker. Can we ping, right? We should be able to ping 172.22.34.62. And the ping works great, as it should, right? And oops, and then we're going to come back over here and not ping. Are we going to pull up the... Okay, yeah, so it wants us to try the FTP. So we're going to say FTP 172.22.34.62. Now, should this work? From PC2, no. We should not see a username prompt. In fact, we're going to have the trying to connect, and it should time out because it's being blocked. Yeah, air opening timed out on us, right? So now let's go ahead. We'll open the web browser up. And give me a second here to get the web browser opened up. Where are we at? Mid browser, web browser. And we are going to enter the IP address, and this is going to take a second here. So we'll give it a second there, and there's our web browser. So let's go ahead on the web browser here, and we're going to type in, what do we got here? 172.22.34.62, and hopefully that's going to be enough. It filled in the HTTP, and so you can see Cisco Packet Tracer, we get the welcome, and then we're able to see what's going on, right? So we're getting fed back the information here that shows us that this is successful, right? That we've got the small page, right? Hello world, the copyrights. And so here's all your copyright information. We've got the image page. So this is an image of Packet Tracer, not loading, but that's okay. And then the image file not found because the file's not there. So it shows that HTTP access is working. So now if we come back to the router here, let's do this. If I were to say, do show IP access list, HTTP underscore only, right, and narrow it down, take a look. We get to see that it's matching, right? We see how many matches we've got, or I should say how many hits we've had on this ACL is another way to say it. So we see the hits, right? How many times the ACL has been matched based off of the packets that it's filtering. And again, remember, this is a stateless. There is no state information being tracked here, right? It's simply looking in at the layer 3 and layer 4 information to make a decision on a packet by packet basis. All right, guys. Well, that is going to wrap up Packet Tracer activity 4.2.2.10, where we took a look at extended ACLs. And let's see, that is about it. I'm going to figure out, like I said, I cannot remember for the life of me. There's a way to see that the ACL is applied to the interface, and I thought it was that show interface command, and maybe I just missed it, but that was the command I thought it was, but I'll figure it out here as soon as we wrap up and go into 4.2.2.11. All right, I will see you guys on Tuesday night.